Hey everyone, Omogonix here and welcome back to a brand new Godot tutorial here on the channel. A while ago I started making a tutorial series on how to make a basic first-person horror game in Godot. I was getting close to finishing the series when my old PC stopped working and I lost the project files. Whilst I was kinda upset upon realizing this, I quickly started to see it as a blessing in disguise, since my Godot skills have improved a bunch since starting that series. So starting over and making a new series which is better structured and more thought out was an appealing idea to me. So welcome to part 1 of my new and improved tutorial series on how to make a horror game in Godot. Again, sorry about not being able to finish off the old series. I'm sure I can make it up to you guys with this one. Before I begin, I just do want to say that unlike my previous series where I release one part at a time, I won't be editing and uploading any parts of this series until I have them all done and recorded. The game I'm making for this series will also be up on my itch.io page if you want to check it out, so I'll leave a link in the description for the game I made for this tutorial series if anyone would like to check it out. So with all that out of the way, let's get into this new tutorial. First off, I want to talk about planning games since I do consider that to be an important part of game development. Before we start making a game, we need to come up with a plan for it. The difficulty of planning a game can depend on the size of your game. If you're making a small game, the planning for it will probably be easier. If you want to make a big game, the planning will probably take more time. Here's an example of the basic plan I wrote for the game I'm making in this tutorial series. Since this game is smaller, the planning didn't take long at all. You can plan your games however you like, whatever works best for you. You can be very descriptive if you want to, or just write basic outlines for things. If you're working in a team, it'd probably be best to be as descriptive as you can be. And planning doesn't just include words, it can also include concept art as well, or basic layouts for levels you want to make, that kind of stuff. Here's a few examples of concept art that have been done for my games before. Usually when planning smaller games, I'll just do a list of things that will happen in the game. I might even write a list of some of the things I want to make as well. The way I plan games is never consistent. Every one of my games is planned in a different way depending on its size, style, gameplay, etc. For example, when planning a project, you could include things like the project's title, the genre, the art style, a short description of what the game is about, an ordered list of events that will happen in the game, the gameplay features, characters, all that kind of stuff. Make sure when planning your games that it gives you an overall good view of what you would like to do for your game. I also recommend creating a to-do list, which I do for most of my games. I find that to-do lists can help you get things done more efficiently, since you already have an idea of the things you'd like to do and aren't just sitting around for 20 minutes thinking to yourself about what you should do next. So anyways, now that we've discussed planning, let's move on. So before we do start making a game in Godot, we need to of course download the engine. So Godot's website is godotengine.org, so that is the website name, and when you do end up getting taken to the Godot website, you will see that there is a button where you can download the latest version of Godot. So as of recording this video, the latest version of Godot is Godot 4.3, and Godot 4.3 is the current version of Godot which I use. So what you can do is you can just click the button here to download the latest version. And then we have two different buttons to pick here now. So you can either choose the top option or the bottom option. So the only difference between the two is that one has C# support and the other doesn't. Now C#, for those of you who don't know, is another programming language. The primary language of Godot is GD script. That's Godot's own language, and that's what we're going to be using for this tutorial series. However, if you want to download the C# support version, just in case you want to use C# in the future, that's totally fine. I do recommend just downloading the top version though, since I'm not going to be using C# in this tutorial. But like I said, if you want to download the C# support version, go ahead, that's totally fine. But yeah, so once you've decided what version you want to download, just click on the button, and then boom, now you will be downloading Godot, and then all you got to do now is just select the folder where you want to download it, and then boom, So here I have my folder where I like to download my Godot versions. So right now I have Godot 4.1.1 and Godot 4.3. So once you download your Godot version, it will come as a zip file. So what you'll need to do is extract it. So what you'll do is you'll click on your zip file, go right click, and then go extract all. And then you'll just choose the path where you would like your Godot folder to extract to. And then just press extract and boom, it'll all be ready. So I'm not going to go extracting mine since, as you can see here, I've already got the folder extracted. So once you do have Godot extracted and ready, what you can do is just open up the folder, and then you will see two different icons here. So just click on the top one, and what this will do is this will then open up the Godot Engine Project Manager, which is where we can manage our projects. Alright, so once you have Godot downloaded and you've opened up the project manager, now what we can do is create a new project. So as you can see here, I've already got a bunch of my own projects already, but what we're going to be doing now is we're going to be going create. So you just want to press on the create button, and now that should bring up this little menu here where we now create our new project. So for my project name, I'm just going to call this, I'll just call it Horror Game. And you can of course select the path of where you would like your project to be. So I'm just going to leave my path the way it is. I think this path is fine. And then you can select your renderer, so forward plus, mobile, or compatibility. So basically forward plus is basically the best looking renderer in Godot. It's the most advanced available. As you can see here, there are some dot points explaining exactly what these renderers do. So for forward plus, for example, it says supports desktop platforms only, advanced 3D graphics available, can scale to large complex scenes, uses rendering device backend, slower rendering of simple scenes. So then we have the mobile, which says supports desktop plus mobile platforms, less advanced 3D graphics, less scalable for complex scenes, blah blah blah, you get the point. Basically, forward plus is the best renderer. Then compatibility, this is for basically just lower end PCs. As you can see here, it says intended for low end older devices. So yeah. So what I'm going to be using for this tutorial is forward plus, since my PC can handle this. However, if your PC is on the older end of things and you need to use compatibility, that's totally fine. I totally understand. But yeah, so then once you've got all that set up, we can then go create and edit, and now we'll be creating a new project. So now that we've created our new project, we are now in an empty scene. So what I want to do to start off here in this tutorial is I want to start off by making a simple level so then we can test out our player movement, since I do want to make a player for us to be able to test out. So what we're going to do to start off with is, since when opening up a new Godot project, what will happen is you are taken to a new scene, to an empty scene. What you want to do is in the top left where it says create root node, you want to select 3D scene, since we're going to be making a 3D game, of course. And then what I'm going to do is I'm going to rename this node, so I'm just going to double click on it and I'm going to rename it to level, and boom. So what I recommend you do as you do work on your game, of course, is that you press Ctrl S to save stuff often. And whenever you save a new scene that you haven't saved yet, what will happen is when you press Ctrl S, you'll then get taken to this new menu here where we need to save the scene as. So what I recommend usually is creating a new folder for your scenes. You can call it something like levels or scenes if you want to. I'm just going to call mine levels. So here I have my levels folder, and then I'm going to save my file as level.tscn, go save, and boom, so now I have a levels folder with my new level in it. So be sure to press Ctrl S often as you do work on your game to make sure that if your game does crash, I mean if your engine crashes or if your PC crashes, then of course you will have, you know, everything back to where it was needed and you won't lose any progress. So yeah. So what we're going to do first off is we need to add in a floor for this scene. So what we're going to do is in the top left hand corner where you see the plus icon, you just want to click on this. And what this will do is this will allow us to add a new child node into our scene. So what I recommend you do is you search up static body 3D. So what a static body 3D is this is basically just like, this is what's used for basic scene collision for things like floors and walls. Basically, it's used for objects that aren't meant to move in the scene. That's why it's called a static body, because it's a body which is just meant to be, in place. It's not really meant to move at all. Of course, they can still move if you animate them, but they can't move via any other force. So it's not like a rigid body can collide with a static body and then cause it to move. That can't happen with static bodies. They're just always in the same place. So yeah, so that's why for floors and walls, stuff like that which isn't meant to move, we usually use static bodies. So I'm going to get out a static body 3D, and what I'm going to do is I'm going to rename this static body 3D to floor, so we know it's our floor. And then what we're going to do is oh wait, why does it, oh yeah, that's right, we need to add a collision shape. So now what we need to do is we need to add a collision shape to our static body 3D. So you just want to right click on it, and then you want to go add child node, and then we're going to select collision shape 3D. So you just want to search that up. And so what collision shape 3Ds do is they provide a shape to our object, a collision shape to our object. So now when you've got your collision shape selected, to the right here in the inspector menu, you should see that it says shape empty. I'm going to click on this, and then we're going to get out a new box shape 3D, since I want my floor to be rectangle shape. So as you can see now, our static body actually does have a shape to it. You can see the collision shape box around it. So now what we're going to do is we're going to actually add like a visual to our object now, since we want to have a visual for our floor as well. So we're going to right click on our static body, go add child node, and we're going to search up mesh instance 3D. So basically what a mesh does is this basically provides a visual for our object, so then we can actually see something. Its description here just says node that instances meshes into a scenario. So yeah, basically it just provides a visual for your object in the scene. So what I'm going to do is I'm going to double click on this, and boom, now I've got a mesh instance 3D. So when you've got it selected, in the inspector menu to the right where it says mesh empty, I'm just going to go new box mesh. And now, as you can see, we have a box. So now my floor static body 3D is now just a box. And we want to make this a proper floor now. So what we want to do in order to scale this, and by the way, there are a few rules when it comes to scaling things in Godot. I don't always follow these rules myself, but I thought I'd just tell you guys anyway, just in case you are someone who wants to do things, very proper. So when it comes to scaling things in Godot, particularly static body 3Ds, it's never recommended that you actually scale the static body 3D itself. And the reason as to why, well, we'll see here. So when you do scale a static body 3D, so as you can see I've just scaled it like a floor, what you'll notice is that we have a caution sign now. And what does this say? It says, with a non-uniform scale, this node will probably not function as expected. Please make its scale uniform and change the size in children collision shapes instead. So basically what uniform means is that the X, Y, and Z axis all have to be the same. So if I set the X, Y, and Z axis on this static body 3D to 5, there is now no issues because it is now in uniform scale. However, if I do, 5, 1, and 5, it is now in non-uniform scale. So what we need to do in order to actually scale our static body 3D is we need to actually scale the collision shape instead. But even then, it's not recommended to just, scale the collision shape normally, since guess what? We get the exact same error pop up on this as well. And it says to change the size of its shape resource instead. So what that means is if we actually select our box shape here on the shape property on our collision shape 3D, you'll actually see that we have some variables here. So we have the size, and then we have these few other things here which don't matter at all. What we're going to be focusing on is the size. So we can actually change the size of our collision shape 3D's box shape, and we can just do, like, let's say for example 2, 7, and 4, so this is a non-uniform scale, but as you can see, we now have no errors. So basically what we need to do in order to scale scale our floor in our scene is we need to scale the actual box shape resource itself. So I'm going to be scaling this as like a 15 by 1 by 15. So it's 15 on the x-axis, 1 on the y, and 15 on the z. And yeah, as you can see, there is now no errors. So you might be thinking to yourself now, well, how do we scale the mesh? Well, with a Mesh Instance 3D, there's a few different ways to scale it. So you can either change the scale of the transform itself, so you can just go like 15 by 1 by 15, so then it's the exact same scale as the collision shape. And as you can see, when we actually change the transform scale of our mesh instance, we don't get any errors, and that's because there's, you know, no problems with just scaling the transform of a mesh instance 3D. However, when it comes to scaling the transform of a collision shape or a static body 3D, there usually is problems there. You know, like I usually do it on occasion. You know, I scale the collision shapes or the static body 3Ds on their transform, and I don't really notice any issues ever. But you know, I'm just showing this, of course, because it's what Godot recommends you do. So yeah. And then the other way of scaling a mesh instance 3D is you can also just select on your actual mesh property here. And as you can see, we can also just change the size in our actual mesh resource as well. But yeah, so here is our floor. It is 15 by 1 by 15. And yeah, so now we're actually just gonna save that. And boom, so that's gonna be like our basic floor for the scene. I wanna also add like a basic material to it as well, just so that it's not plain and white. So what I'm gonna do is I'm gonna select our mesh instance, go geometry, and where it says material override empty, I'm just gonna select new standard material 3D, and this will create a new material for the object. And I'm gonna scroll down to, so you know, I just click on the material here, then I scroll down to albedo, where it says texture empty, just click on this, quick load, and I'm just gonna use the basic Godot icon as like a texture for now. And then where it says UV1, I'm going to change the scale of this from 1, 1, 1 to 3, 2, 1, and the reason as to why is because that is what you do to properly scale a texture on a box, is you have to do like a 3 by 2 scale for the X and Y axis, and then boom, as you can see, we now have our Godot logo being projected onto the floor. Alright, so now that we have the basic floor in our scene, so then we can test out our player, now let's actually make the player itself. So what we're going to do is, where we have our scenes here, you just want to click on this little plus icon, and boom, now we have added a new scene. So you want to create a new 3D scene, and I'm just going to rename this to player. And then what we're going to do is we're actually going to change the type of our parent node. So I'm going to right click, go change type, and we're going to set this to character body 3D. So a character body 3D is a node that's specifically made for character movement, so that's why we're going to be using that. And also the character body 3D node also comes with like a basic first person, and also it can be used for, you know, third person and stuff like that, but it also comes with like a basic player controller script that you can use for like first person and third person movement. The only thing is though is that you need to actually, you know, program the camera movement yourself, so that's what we'll be doing later on. So now that we've got our player node in the scene, we need to add collision shape to it, of course. So what we're going to do is we're going to right click, go add child node, and we're going to add a collision shape 3D. I've already explained what this is. And then with your collision shape selected, where it says shape empty, you can select whatever shape you want to. Now what I'm going to be doing for this tutorial is I'm going to be using a capsule shape 3D. You feel free to use whatever, you know, shape you want to though. If you want to use a box shape or a capsule shape, that's totally fine, because even sometimes I use box shapes for my characters if I find that it works better for the collision. But yeah. Alright, so now we've got a capsule shape for our player, and what I'm going to do now is I'm now going to select my player again, go add child node, and now we're going to add another mesh instance 3D. So this mesh instance is going to be a capsule as well. So where it says mesh empty, I'm just going to select capsule mesh, and boom. So now we have a capsule for our player. So what we're going to do now is we're going to save, and I'm going to save this into a new folder. So I'm going to be creating a new folder just called player, and this is where I'm going to be saving stuff specifically for the player. So I'm just going to be saving my player scene into a player folder, go save, and boom. And now what I'm going to do is, with my player selected again, I'm now going to create a new child node. It is going to be a node 3D, so just a standard node 3D, nothing special. And where we want to place this is near to where our actual player head is. So our node 3D will be sort of around here, you know, imagine to where your player's eyes would be, right? Imagine where your player's eyes are. That's sort of where you want your node 3D to be. And by the way, just something that I wanted to mention as well is see this up here, which shows basically our X, Y, and Z directions. Well, wherever the Z is pointing, that is backwards. So Z is pointing this way, which means that that is backwards. That means that this way is forwards. So whenever you, let's say for example, you want to create something which is based on direction, right? Like, you know, like a proper character. Well, to make sure that their rotation is correct, make sure that the Z, make sure that where they're facing backwards, that's where the Z arrow is pointing as well. So make sure that the Z, the blue arrow, is pointing you know, where they're facing backwards. So facing forwards should be opposite of the blue arrow. So now when you add your node 3D into the scene, rename it to head. And the reason as to why is this is going to be our player's head. So this is where our camera will be attached to. So now what we're going to do is we're going to right click on the head node, and we're going to go add child node, and this will be a camera 3D. So you want to make sure that your camera is pointing in this direction, so whatever is opposite to your blue arrow, your Z axis arrow, make sure that's where your camera is pointing, because that is forwards. Now there is a bunch of settings for your player camera. For example, you can change the FOV if you want to, the near and far planes. There's a bunch of stuff to play around with here. I'm not going to be playing around with any of this stuff in this tutorial since it's not really needed. However, we might play around with it later on in later parts. Feel free to play around with it though if you want to now though. So now that we've got our basic player set up in terms of its nodes, now we can actually get to the scripting. So to start off with the scripting, what we're going to be doing is I'm going to be selecting our player here, and to the right on the inspector menu down the bottom where it says script empty, just select empty and then new script, and now we're going to be creating our new script for our player. So this script will just simply be called player.gd. You can rename it if you want to, and you can also you know, change the file path of where you want it to be saved to. I'm just going to be saving it in my player folder, of course. So yeah, so once you've got all that done, what I recommend you do if it's not already selected is you go to where it says template, and if node default is selected, just change it to character body 3D basic movement, as this will give you the basic movement needed for your character body 3D. So now we're going to go create, and boom, now we have our basic script generated for our character body 3D. So whilst this is pretty much done in terms of our player movement, there are still a few changes we need to make, mainly in terms of these inputs here. So as you can see where it says UI accept, UI left, UI right, UI up, UI down, we need to actually change these to our own inputs. So what we're going to do is we're going to go to where it says project up here, and then project settings, and then you want to switch to the input map, and then here is where we actually make our inputs for our game. So where it says add new action, you just want to type in an action. So for example, you might want to type in forward for the player going forward. So for our forward action, what you want to do in order to assign a key to it is you want to select the plus icon, And then I'm just going to press W, since W is usually what's used for walking forwards in a game. And now as you can see, once I've pressed W, it shows up here, and then we can just press OK, and boom, now our W key on our keyboard is assigned to the forward action. And then we can also have backward, and then we can also have left and right, and jump as well if you want to. So now I'm just going to assign all these keys. So for backward, I'm just going to select the plus icon, then I'm going to go S, boom. Now as you can see, the backwards action is assigned to the S key, or I should say that the S key is assigned to the backwards action. And then left will be A, D will be right, and then jump will be the space bar, of course. And boom, so now we have all our actions assigned with their proper keys. And then what you want to do in your actual player script is you now want to change the names of these actions here to the actions that we've just made. So for this line of code here on line 14 and 15, this is actually used for our jumping. So where it says input.isActionJustPressed UI accept, what we're going to be doing here is I'm going to be changing this to jump. And boom, so now our jump action is assigned to the jump function in our script. And then we're going to be replacing UI left, UI right, UI up, and UI down with our proper actions. So UI left will just now be left, and then UI right, this will now just be right, and then UI up will now be forward, and then UI down will now be backward. And boom, so now we've got all our proper inputs assigned to the actual script. Alright, so now that we've got our basic player script sorted out, now what I'm going to do is I'm going to go back into the 3D view of my scene. Oh, and by the way, if you want to switch between your script view and 3D view, you can just go up to the tabs here, go script, 3D, and you can just switch between them views. And so anyways, what we're going to be doing now is, now that we have our player script connected, what we're going to be doing is we're going to be selecting our head, so the 3D node that we made earlier. And then where it says script empty in the inspector, we're just going to be going empty, new script. And you can call this script what you want to. I'm just going to be calling this fp_cam, since it's for the first person camera. And I'm going to be saving it into my player folder once again, so then I'm just going to go create. And boom. So now here's what we're going to do. So I'm just going to start off by getting rid of the starter stuff here. So what we're going to do is we're going to start off by creating a new variable. So this variable will be called sensitivity, since this is going to be for the sensitivity of our actual, our looking around. So when the player is looking around, we'll be using our mouse. So this will determine our mouse sensitivity when looking around. So the sensitivity by default will be set to 0.2, since this is what I find to be a good default value for when doing the sensitivity of my player camera. So that's the only variable that we need for now. And then we're going to be writing a new function. So we're going to be writing func_input. And where it says input event, just select this one right here. And boom. So now we want to press enter to indent, and we're going to write if event is input mouse, if event is input event mouse motion, so you want to do this, and we're going to do the 2 dots again and then indent once more. Then what we want to do is we want to get our parent object, which is the player, so we're going to write get_parent dot rotate_y. So what we're doing here is we are going to be rotating the player on its y-axis. So that basically just means like this. So turning it around left or right. That is the y-axis. So we want to do parentheses. And then we want to do deg_to_rad. So what this does is this basically converts the degrees to radians. So if we actually go to like, let's say for example our player here, right? As you can see with the rotation, it is in degrees. So the little dot that you see there, the little circle that is like to the right of the number, that means degrees. So what we're going to be doing is for this rotate underscore y value, we need to actually convert degrees to radians. So inside of the parentheses where it says deg to rad, we need to write minus event dot relative dot x, and then we need to times that by the sensitivity. So basically what's going on here is depending on how our mouse is moving. So if we want to rotate our player left and right, obviously what we need to do is we need to actually move our mouse left and right. So depending on our mouse's left and right movement, what will happen is this line is meant to rotate our player left and right depending on our mouse movement. So that's what this line does here. So yeah, we're rotating our parent object, which is the player, since that is a parent object of the head. And we're going to be rotating our parent object on its y-axis, depending on the mouse movement. And then this time what we want to do is we just want to write rotate underscore x. So we're going to be rotating the actual head object this time on its x-axis. So the x-axis, in case you don't know, is up and down. So this is for making our player look up and down. And so what we're going to be doing is we're going to do rotate underscore x, and we want to do the exact same thing as before. So we're going to do deg underscore to rad, and then minus event dot relative. And then this time instead of dot x, we want to do dot y. And then we're going to do times sensitivity once more. So yeah, this is now going to be our rotating the actual player head itself. So this line here rotates the player left and right depending on our mouse movement. Then this line here rotates our actual player's head on its x-axis depending on the mouse movement. So if our mouse is moving like this rotates our player left and right. When our mouse is moving like this, it rotates our player's head up and down. Now what we need to do is we need to actually clamp our player's head rotation, so then when we look up and down, our player's head can't just 360 all the way around. So then it's only we need to make it so then the player can only look up and down. So when you look down, you can't look behind you and continue rotating all the way around. We need to actually clamp that movement so then the head is actually proper and doesn't go all over the place. So what we need to do is we need to go rotation.x equals clamp and then parentheses. Then we write rotation.x and then we do a comma. And then what we need to do here is we then need to enter in the minimum and maximum values of our camera's clamp. So what we need to do is we need to write deg underscore to rad, and we're going to do -90 for the minimum value of the clamp. So basically this is for when the player is looking down, I'm pretty sure. And then we do comma, and then deg underscore to rad, and then 90, and this is for clamping the player's looking up value. So yeah, and boom, that is how we do the actual player head movement for our player script. So now what will happen is with our regular player script and our player head script combined, this will create our first person movement. So what I'm going to do now is we're going to switch to our 3D view. So here we have our player, it is all done and complete. Alright, so now that we have our player done, what I'm going to do is I'm going to switch to my level scene. Good, and now here we are in our level scene. So what I'm going to do now is I'm now going to click on this little icon here, and what this does is this instantiates scenes into our into a scene. So for example, we can just click on this icon, and as you can see, we have our level scene and our player scene show up here, so we can actually instantiate a child scene. And I'm going to be selecting the player here, and boom, so now we have our player in our level scene. So I'm just going to position my player a bit up, there we go. And now we can just press Ctrl S to save. And now what we're going to do is we are now going to press the play button to test out our project. And so before you test out your project for the first time, if you press the play button, you will have this pop-up open up here, which says no main scene has ever been defined. Select one. You can change it later in project settings under the application category. Now there is another easier way to change your main scene as well, which I will show you guys how to do. But yeah, so what I recommend you do is you either just go select or select current if you are trying to test from the scene that you do want to be your main scene. Just select current, and there we go. And now as you can see, our player is working. So there are a few kinks to solve here. For example, as you can see, there is no lighting in the scene. I will show you guys how to set up some basic lighting. And also our mouse is visible. We don't want our mouse to be visible, so I will show you guys quickly how to do that before ending the tutorial as well. But yeah, as you can see here, we have some basic first-person player movement. So we're just going to stop the scene, just press on the stop button to stop it. And now what we're going to do is we're going to make it so then we actually have this sort of lighting in our scene, because as you can see here, right, we have lighting, but then when we test, there is no lighting. So why is that? Well, the reason as to why is because what we're doing right now is we're just previewing the lighting and environment. So if you press these buttons here, so if they're blue, that means it's being previewed. If they're off, that means it's not being previewed. So this right now is actually how our lighting looks. So what we need to do is we need to actually add an environment and light into our scene. So with the level node here, we can just go right click, go add child node, and we can just write directional light 3D, and we can add a directional light into our scene. So now what we can do is we can now rotate it. So I just want to rotate it on its x-axis, so then it's facing down like that. And you might be thinking to yourself, well, how on earth do we actually get shadows? Well, what we do for shadows is we just click on the shadow tab here, go shadow enabled, and boom, now as you can see we have shadows. So depending on the direction you want your shadows or your lighting to be in, you can just, change up the transform rotation here. And that will actually change up how things look in terms of the lighting. You can also change your light color as well if you want to. Not really that important for this part of the tutorial, but just in case you want to change your lighting, you can change the lighting color. So with the environment, you can either A, just go add child node and then type in environment to add in a world environment, or B, you can do this. So where you have the three dots here, what you do is you just make sure that you're previewing the environment first, and then click on the three dots. And then what you do is you then just press add environment to scene, and boom, now you have a environment preset added to your scene. So now we actually have some lighting. So if I actually, so we press Ctrl S to save, and then if I test out my scene, as you can see, we now have proper lighting in it. Alrighty, so what we need to do is we need to go into our player's head script, and what we need to do right here is we need to create a new ready function. So we're going to go func_ready. So what the ready function does is this makes things happen at the very start of the scene. So as soon as a scene is ready, that's when the ready function happens. So what we're going to be doing in our ready function is we're going to be entering in the following. We're going to be doing input.set mouse. I think it's set mouse mode. What is it again? Or is it input.mouse mode? Oh, I think it's input.mouse mode. So if you do input.mouse mode, is it? Yeah, I think it is. I think it's input.mouse mode, right? Anyways, we'll try this for now. I think it's just input.mouse mode. But anyways, what we do is we go input.mouse mode. Then we do input.mouse mode captured. So what this does is this makes sure that our mouse is no longer visible, and it's just always in the middle of our actual game window, so it doesn't move around and stuff like that. It's just in the middle of our game window. So yeah, so let's go play and test it out. And boom, it works. So yeah, when you write input.mouse mode and you do equals input. So when you do input.mouse mode equals input.mouse mode captured, that is what you do for setting the mouse mode. Also, the reason as to why I was a bit confused before is because another way of setting the mouse mode, which I usually always do, is I just go input.set_mouse mode, and then you can set the mouse mode like this. So yeah, just whatever way works best for you. They both do the exact same thing, but yeah, input.setMouseMode or input.mouseMode equals, both work the same, But yeah. In fact, I'm probably just going to use input.setMouseMode since that's what I use most of the time. It does pretty much the same thing as you can see. So yeah. Now, as you can see, when we actually move around, we can actually fully look and move around. Now we don't have to worry about our mouse going off the screen since it's always attached to the middle of the screen and it is always invisible. And also with the clamp value you can tell that it's working if when you're looking down you can't look down anymore, and if you're looking up you can't look up anymore once you look fully up. So yeah. So anyways guys, that's pretty much the end of part 1 to this tutorial series on how to make a horror game in Godot, or more specifically how to make a first person horror game in Godot. I don't exactly know what I'm going to title this series yet, but you know, we are going to be making a first person horror game in Godot, so that is what the series is about, so yeah. But anyways, be sure to like, comment and subscribe for more videos like this. Be sure to check out the other parts in the series as well. And yeah, I'll see you all next time, and bye bye.